In this one, the objective is going to be to write the equation for linear, quadratic, and exponential. Now, I'll go ahead and give you a hint that quadratic questions on the state tests at the end of the year, it never asks you to write them. So really, we just have to be able to know when to recognize them, but we do have to be able to write linear equations. We do have to be able to write exponential equations. So, just doing these all three together. A linear equation, if you'll remember, is y equals mx plus b. M is the slope. B is the y-intercept, or the starting amount. So we write those very frequently, right? Anytime you are adding or subtracting the same amount each time, that is linear. Quadratic equations we don't have to write, but you should be able to recognize it, and it's good practice to get in your notes anyway. Ax squared plus bx plus c. If you'll remember from level 2, we use that formula a lot so that Desmos will write the equation for us. Exponential equations are written as y equals a times b to the x. A is the initial amount, so the starting amount, initial amount, they mean the same thing. B is the base. So for all of these problems, we're going to figure out whether it's linear, quadratic, or exponential. But like I said, we're going to focus on linear and exponential because we don't generally have to write quadratic functions. And then we're going to write the equation for it. So the first one, bacteria can multiply at an alarming rate when each bacteria splits into two new cells each hour, thus doubling. Write an equation that represents the total number of bacteria, B, after X hours if we start with one bacteria. So this gives us a lot of information. The first thing we have to do is we just have to figure out which situation it is. The hint word here is that guy, doubling. Doubling is an exponential word. It means we are multiplying by 2 each time. So I know that my equation is going to start off with y equals a times b to the x. And I just have to figure out what a and b are and then make sure that my variables match. A is the starting amount, and if we read this question back through, we know that we start with one bacteria. So A is going to be 1. B is the base. It's what we're multiplying by each time, and it gives us the base. The base here is that we are doubling, or we are multiplying by 2 each time. All right, the last thing I'm just going to check here is that this guy, it does give us X hours, so I can leave that. But it doesn't want y equals. And that's important here because on the state test, if your letters aren't right, you won't get the question right. The total number of bacteria has to be a capital B. So if I wrote y equals 1 times 2 to the x, it would not be correct. It has to be b equals 1 times 2 to the x. The second one says an adult takes 400 milligrams of ibuprofen. Each hour, the amount of ibuprofen in the person's system decreases by about 29%. Write an equation to represent how much ibuprofen, I, is left in a person's system X hours after taking it. So the first thing we have to do is we have to figure out, is this linear, is it quadratic, or is it exponential? There are 2 hint words in this. It decreases by 29%. Anytime you see a percent, that is exponential. So I'm going to start with the same format. It's going to be y equals a times b to the x. A is my starting amount, so I'm going to look for how much I start out with. I start out by taking 400 milligrams of ibuprofen. I'm going to start with 400 milligrams. It's going to decrease by 29%. Now that gives us the rate, not the base. If you remember this problem right here, it doubled. I multiplied by 2 each time. But if I'm decreasing by 29%, I'm not multiplying by 29%. If you remember, we always do, it is 1 plus if it is growth or 1 minus if it is decay. Decreasing is a decay word. So 1 minus 29% as a decimal is 0.29. And that's going to give us our base. 1 plus if it's growth or 1 minus if it's decay. 1 minus 0.29 is 0.71. I'm just going to check my variables. If I'm allowed to use x, which I am, but it does not want y, it wants a capital I. So make sure that your variables match at the very end. Make sure that you're typing it incorrectly. The third question says, Angel mows lawns and picks weeds during the summer to earn money. She charges $10 to mow a lawn and $7 to pick weeds. Over the summer, she earns a total of $178. This one's a little bit strange. It is a linear equation because I'm adding and subtracting the same amount each time. She charges $10 to mow a lawn and, which is an adding word, $7 to pick weeds. So we're adding $10 every time she mows grass. We're adding $7 every time she picks weeds. That is linear. Now, normally these are given in y equals mx plus b format, but in this case, it already kind of tells us the story if we use our hint words from when we wrote linear equations. She charges $10 per lawn, so that would be $10 per lawn, and she earns $7 by picking weeds, so $7 every time she picks weeds, and she earns a total, which is my equals word, of 178. This one doesn't tell us which variables to use, so I'm allowed to pick. I just went ahead and picked X for how many lawns she mows and Y for how many weeds she picks. The last one says, in 1985, there were 285 cell phone owners in a town. The number of subscribers increased by 75% each year after 1985. Write the equation for the number of cell phone owners. C, there are X years after 1985. So if I read through this one, I see increased by 75%. That is exponential because I see percentages. So I know I'm going to start with y equals a times b to the x. A is my starting amount, and so I'm looking for how many cell phone owners did we start with. And we're starting in 1985 in this story, and we're starting with 285 cell phone owners. B is my base, but this one doesn't tell me the base. It tells me the rate. It tells me we're increasing by 75% each year. So if you'll remember up here when we did it, it's 1 plus if it's growth, or it's 1 minus if it's decay. Increasing is growth. So 1 plus 75% as a decimal is 0.75. And that tells me that my base is 1.75. I'm just going to put my variables here. X years, so the amount of time can stay as X, but I should not have Y equals. I should have C equals. Again, make really, really sure that your variables match what they are supposed to be.